Hello everyone. Today in this third session we will discuss engine ignition system, a system which initiates the combustion process by a spark in an engine cylinder is known as the engine ignition system. In SI engine, to initiate the combustion process, an ignition system is required. Also, in SI engines, we know that as the compression ratio is quite low, and second thing, as self-ignition temperature of fuel is high, so ignition system in combustion process plays a quite important role. Here, in ignition system, an electrical discharge, or you can say heat energy, is produced between the two electrodes of the spark plug. Now, this electrical discharge initiates the combustion process in the engines. So, for uniform combustion process under different load and different speed condition, this ignition system has to generate spark in each cycle and at very correct time. Now, we will see what are the energy requirements for an ignition system. Here, for a homogeneous mixture, in order to have initiation of combustion process, a spark energy of 10 megajoule for few microseconds is required. Usually, when the spark energy is of 40 megajoule for 0.5 microseconds, then a very reliable ignition can be obtained. So, in this relation, to generate this much amount of the spark energy, a sufficient large voltage across the electrodes of the spark plug is provided. So, this high voltage in the range of 8000 volts to the 20,000 volts or even more. So, here ignition system has to obey law of conservation of energy also, such that energy balance within the engine must be appropriate. The energy balance can be maintained in terms of external source of energy, chemical energy, and the heat energy rejected to the atmosphere. So likely you can have the energy balance in the ignition system also. Now we will focus the requirements of an ignition system. Basically, we are identifying what are the characteristics of an effective ignition system. The very first one, it must provide a sufficient spark between two electrodes of the spark plug at a very correct time in every of the cycle of the engine. Secondly, it also works very efficiently for different load as well as the different speed conditions of the engine. Next, it must be a lightweight and reliable in its service also. And it must be a compact in design and structure so that it can be maintained very much easily. And at last, it must be cheap and easy to handle. Generally, the ignition system having the three types: battery ignition system, magneto ignition system, and the electronic ignition system. Before going for the types of the ignition system, we will see what are the basic components required for the battery ignition system. The first essential component which we have seen, which is the battery of the ignition system. Generally, 6 volt to the 12 volts battery is utilized in the automobiles. So, this battery provides electrical energy to the ignition system. Next, we are having the ignition switch. Using this ignition switch, ignition system can be turned on or can be turned off. This ignition switch is present in between the battery and ignition coil, which is the part of primary winding. The third component is ignition coil. The function of ignition coil is step up the 6 or 12 volts of the battery to a high voltage, say up to 8000 volts to 20,000 volts or even more. It is provided with a ballast resistor which regulates the current. Also, this prevents the overheating of the spark plug. Then we are having a contact breaker. It is a kind of mechanical device which is making and breaking primary circuit of the ignition coil. Further, we are having the distributor. The function of the distributor is to distribute the ignition pulse, you can say the ignition energy, to the individual spark plug at a very correct time and in correct sequence. In correct sequence means according to firing order of 4-cylinder or 6-cylinder engine, it will distribute the ignition pulse or ignition energy to the respective spark plug. And then at last we are having the spark plug. Spark plug having two electrodes. In these two electrodes, when a high voltage is applied, it produces a spark between the gap, which is the source of heat energy to initiate the combustion process. So these are the basic components with which an effective ignition system is working. Now we will get to know some more details about the battery utilized in the ignition system. In ignition system, the electrical energy required, which is provided by storage batteries. These batteries are of 6 volt or 12 volt. These batteries are charged using a dynamo which is driven by the engine itself. Here in batteries, chemical energy is exactly converted into electrical energy. Now, life of the battery can be of 2 years or even more. Nowadays, maintenance-free batteries are also available. Now, we will see in SI engine what different types of batteries we can utilize. So generally, lead acid batteries or alkaline batteries can be utilized in SI engine. Lead acid batteries are used for the light duty engine application, and alkaline batteries are utilized for the heavy duty engine applications. Talking about lead acid batteries, these lead acid batteries are formed by number of cells of potential 2 volts. Number of cells can be connected together in series or in parallel. For 12 volt battery, we have to connect 6 cells of 2 volts. 2 volt cells are connected in series such that positive of the first cell is connected to the negative of the next cell, and so on. Generally, when we are going for the series and parallel connection inside the battery, when we are employing the series connection, in that case, we are having the facility to double the voltage and keep the same ampere. In case of the parallel, we are having the facility to keep the same voltage and double the ampere. Now, we will see how exactly ignition coil is working. Generally, ignition coil stores the energy in its magnetic field in the form of ignition pulse. These ignition pulses are delivered to respective spark plug at appropriate time using high tension ignition cables. So, to complete above task, ignition coil has to step up 6 volt or 12 volt of battery to a high voltage, that is around 8000 volt to 20,000 volts or even more. This high voltage is useful to create spark between two electrodes of spark plug. Generally, this ignition coil consists of primary circuit, which includes battery, ignition switch and ballast resistor. And ignition coil also have secondary circuit, which includes contact breaker, capacitor, distributor and spark plug. Now we will observe how exactly ignition coil is comprises of. Ignition coil has primary coil and secondary coil. Inside the ignition coil, we are also having iron core. So here, in this case, you can see this one is the iron core, which is having a secondary coil first of all around it, and then primary coil around the secondary coil. Now, as I said, inside the ignition coil, as we are having the iron core, around the iron core, first of all, secondary coil is wounded. This secondary coil has around 21,000 turns of 38 gauge to 40 gauge of copper wire. Then, around these secondary coil, primary coil is wounded with about 200 to 300 turns with a 20 gauge wire. One terminal of this secondary coil is connected to high tension cable. So here you can see that one terminal of this secondary coil is connected to the high tension cable, which are exactly further transferred to the distributor. The another terminal of the secondary coil is connected with the primary coil, and then further it is transferred to the contact breaker. In case of the primary coil, one terminal of primary coil is connected to the ignition switch, which you can observe here on this terminal. And other terminal of the primary coil along with the secondary terminal is again connected to the contact breaker, which also you can observe in this second terminal. This whole arrangement is enclosed inside a metal container which forms a neat and compact unit. So this is what about the ignition coil with the ballast resistor. In this next slide, now we will try to understand how exactly spark plug is playing its role in the ignition system. Spark plug is placed at the end of ignition system circuit. Here, spark plug comes in the contact with the air-fuel mixture which is compressed in the combustion chamber at the end of the second stroke of the IC engines. So, in present diagram, you can observe the sectional view of the spark plug. In a given schematic, we are also observing that there is an insulator, there is a metal shield, or you can say the steel shield, and there are the two electrodes. These are the basic elements of any spark plug. Here, insulator is made up of ceramic material which will reduce thermal and mechanical stresses in the spark plug. These two electrodes are made from the high nickel alloy so as to reduce erosion and corrosion which may occur. Out of the two electrodes, the central electrode is connected to the ignition coil with high tension ignition cables. So for this, it does have this terminal which exactly connects the central electrode, and the second electrode is welded to the steel shell, so it automatically gets grounded or getting earth. So when ignition pulses are delivered to the central electrode through high tension ignition cable, it produces high voltage across the gap between the two electrodes and causing it to generate a spark between the two electrodes. And then this spark is exactly quite useful to initiate the combustion process in the SI engines. Now further, spark plug can be of two types, that is hot spark plug and the cold spark plug. Generally, a cold spark plug have short heat transfer path and also have a very small area exposed to the combustion gases, while the hot spark plug have long heat transfer path and have large area exposed to the combustion gases. So generally in most of the automobiles, hot spark plug is preferred.